The U.S. dietary guidelines is sort of a one-size-fits-all approach right now. And I think our Department of Health and Human Services, together with the Department of Agriculture, are considering the next version of the U.S. dietary guidelines. They might look to studies like this to offer a sort of a suite of dietary patterns or suggestions depending on an individual's unique metabolic profile.
If you look at the U.S. dietary guidelines, it seems like there's this assumption that we know that there's one best diet and one best way to eat for everybody. But it turns out that's probably not true. And a new study really helps shed light on that, which shows how two individuals can have dramatically different responses to the exact same food, which really highlights how we are individuals and we might need a more individualized approach. So I'm joined today by Dr. Cristina Nigro, who's a program officer in neuroscience at Baszucki Group, and she has a master's degree in neuroscience and a PhD. And she joins me to talk about this study, which really helps us understand what we need to know as individuals and some tips and tools that we can use to help us better understand what foods are we may respond better to or less well to, and sort of what are our baseline characteristics that may predict that. This is so important so that we can know what is our individual path to metabolic health. Well, Cristina, thanks so much for joining me today.
Thanks for having me. Excited to be here.
Yeah, this is great. I mean, we have the opportunity to work together at Baszucki Group, but now my first time to interview you about this really interesting study that really kind of informs us about how we're all a little different and how we react to foods. But we'll get to that. So before we get into the study, though, tell the audience a little bit more about you. What got you interested into the brain and neuroscience and metabolic health and that whole connection?
Yeah, I mean, I think kind of as far back as I can remember as a young student in high school, I've really just have been so fascinated with the brain, trying to understand what's going on inside our skulls and how that makes us who we are. I also had family background in various neurodegenerative or psychiatric diseases. So my grandmother was diagnosed with Alzheimer's. My great-grandfather had Parkinson's and Alzheimer's disease. And then my uncle was diagnosed with schizophrenia. And I, kind of saw the impact it had on individual lives and was just always wondering what is going on inside of our brains to make this happen. And so figured, seemed like really cool to be a scientist. So I started pursuing that role to understand from that perspective. And then over time, I started realizing that there's other ways to think about the brain and other kind of influences, and started learning more about metabolic health and what we eat and how that influences our brain. And now here working with Baszucki Group, I'm learning more and more. And it's just really enlightening and exciting.
Yeah, well, thank you for that. It is funny how you say you're so interested about, how the brain works and everything. And it seems like it for medical school, at least, or for, when people are thinking about becoming a doctor, it's almost like the brain is like this black box that it either really draws you to it or sort of repels you away from it. It really seems like almost like a polar opposite kind of draw or repel. So good to see that you were drawn to it through your scientific studies. But now, so interesting what we're learning about metabolic health and how it applies to brain health. So the study we're talking about isn't really about the brain at all, but it's about metabolic health and how our bodies respond to what we eat. So the study's called Individual Variations in Glycemic Responses to Carbohydrates and Underlying Metabolic Physiology. And it was published in Nature Medicine. So there's a lot in there, right? Individual variations. So we're talking about how we as individuals aren't necessarily the same as everybody else. And glycemic responses, so it's about how our sugar responds, to carbohydrates, so different versions of carbohydrates, and underlying metabolic physiology and how our physiology sort of impacts that. So the title is really informative, but tell us, with the setup of the study, what are some of the things that stood out for you about how they designed it that were sort of kind of helpful or unique?
Sure. And yeah, you set it up really well. The researchers were really trying to understand how an individual's underlying metabolic, physiologic, molecular profiles shape their response to eating various foods, specifically carb-heavy foods. And they really were trying to see whether CGMs, continuous glucose monitors, are a good way to track individual responses to eating foods. So as a way to do that, they recruited 55 adults, all from the San Francisco Bay Area, with no history of diabetes. And what's cool is each of these individuals went through some pretty serious testing, not just eating meals, which is part of the study, and I'll get to, but undergoing metabolic tests to measure insulin sensitivity and how their bodies handle sugar. And each of the participants wore continuous glucose monitors throughout the study. So they would wear their CGM, and then they would log everything they ate in an app, and the researchers could sync the data to see exactly how blood sugar was changing before and after eating meals.
Yeah, and I like how you talked about the sort of workup, extensive workup they had. It wasn't just one test to see if they were insulin resistant or sensitive. They all underwent 4 different tests to really make sure they were studied pretty deeply about their insulin sensitivity, which was sort of a big core of this study. You know, how do insulin sensitive versus insulin resistant people react differently? And the other interesting thing I thought was, so the amount of carbohydrates, that it was 50 grams of carbohydrates, which a lot of people may not understand what that means, but it's from a low carb perspective, it's a lot of carbohydrates in a meal, but from a standard American diet, it's actually not that many carbs in a meal. So I thought that was kind of an interesting setup too. So tell us about the different carbohydrates that they tested.
Sure. So, you pointed to the 50 grams of carbs. That was sort of a standardized way to compare the various carb groups. So although they each had 50 grams of carbs, the carbs contained in them were slightly different. So 5 of the 7 carb-based meals were starchy meals. Those included rice, potatoes, pasta, white bread, and black beans. And then 2 of the 7 meals were more simple carbs, grapes and mixed berries. And each of the individuals would eat these meals at least multiple times. So the researchers could kind of see how consistent their blood sugar responses were to each of these carb-based meals.
Yeah. And now, so that was one big chunk of the study, was how do they respond to the meals? But the other part was their use of what they called mitigators. So tell us a little bit about that section.
Yeah. So sometimes before eating one of these carb-based meals, the participants were asked to eat a mitigator a few minutes before eating these meals. So there were 3 different types of mitigators that they were asked to try out. One, that fell into 3 groups: fiber, protein, and fat. And so there was fiber powder and pea fiber powder, boiled egg whites, and creme fraiche for the fat. So in some instances, they could see that these mitigators were able to blunt the response of the glycemic response that came as a result of eating the carb-based meal. Well, I'm sure we'll talk more about that.
Yeah. So mitigator just meaning mitigating or being able to sort of lessen the glucose response to the meal. And I think that was, I really like that they added that in there, because we hear all the time, if you're going to eat your carbs, make sure you eat your protein first, or your protein and your fat first, or make sure you get lots of fiber first, like eat your salad before your meal, or, things like that can help with the glucose response. But what are a couple of the big take homes or the main results that you saw?
Sure. I mean, some of them are, more obvious than others. Like the more starchy meals, rice, potatoes, pasta, bread, cause bigger sugar spikes than the fruit-based meals like grapes and berries. And as you might expect, when we're talking about these mitigators, the word that kind of gives a hint as to what they do. Eating mitigators typically did help reduce those spikes. But, importantly, and kind of the main findings of the study is that the effect size differed between individuals.
Yeah. So let's talk about the mitigators for a sec.
Yeah.
So yeah. Tell us about, who had a better response or a less good response.
Yeah. So, I mean, another interesting part of the study is that individuals, although within individual, there was pretty consistent responses across individuals, you might have different types of responses. So for example, you could break people into potato spikers. People who were potato spikers were more likely to have a bigger and longer lasting glucose blood sugar spike as compared to someone who would be labeled a grape spiker. And the mitigators for specifically the potato spikers tended to have less of an effect on blunting or mitigating the glucose response after eating that meal. And that was, the research just included, was because the potato spikers tended to be insulin resistant. And so the mitigation effect really was not able to be achieved because these people had insulin resistance. Whereas grape spikers tended to be more insulin sensitive, and the mitigators did have a bigger effect on reducing that glucose spike.
Yeah, I thought that was super interesting that the people who are insulin sensitive had a much greater impact on the mitigators, and all three of the mitigators, fiber, fat, and protein, whereas those who are insulin resistant didn't. So right away, one of these individualization take-home messages and benefits of a CGM is that, we hear people say, eat your protein and your fat before your carbs and it's going to help. Well, maybe it's not if you're already insulin resistant, and the way you can learn is by wearing a CGM. So, I mean, that was a huge take home for me.
Yes.
What do you think there?
Yeah, exactly. You brought that up. I think that's a big takeaway, is that CGMs are, can be a reliable proxy for individuals to monitor their individual responses. So not only for research purposes, this paper has produced some pretty good evidence that CGMs can help us understand our underlying physiology behind our blood sugar responses. So if an individual has a meal throughout the day, they can check their CGM to have an understanding about how their blood glucose is being affected after eating that meal.
So that's, we talked about the mitigators first. I thought that was super interesting, but now let's talk about sort of the other aspects of the glucose, results, and looking at some of these graphs, and we can put a graph up. So looking at some of these graphs, like you already mentioned, the bread spiker and the pasta spiker and the potato spiker. But what I thought was super interesting is you look at the graphs, and some went up to 220, some, went up to 140, some hardly spiked at all. So what did they find about the differences between individuals who did or did not spike to each of these, type of carbohydrates?
Yeah, it was really interesting. So this figure here shows how people can be broken up by the type of carb responder they were. So they were breaking people into bread spiker, for example, pasta spiker, based on what their glycemic response was following eating that particular carb-based meal. So you can tell some people had a bigger, in terms of higher magnitude or longer duration spike from after eating bread, but maybe a lower spike after eating grapes, whereas another individual might have a larger spike after eating potatoes and a lower spike from eating something else. And although it was a pretty small sample size, so the researchers were careful to not draw broad conclusions based on demographic, ethnic data. They did notice that people of Asian descent were more likely to be rice spikers, which I found pretty interesting, and I think that deserves some more study.
And I'm glad how you mentioned not just the height of the spike, but the duration of the spike too, which is something that maybe doesn't get quite as much attention, because how long it takes to respond to baseline is also really important. So now let's go to this next graph. So this one was super interesting because it sort of broke up the responses specifically by those who are insulin resistant and those who are insulin sensitive to see the difference. So is there one or two main take homes from that graph?
Yeah, just in really broad strokes, you can see people who were insulin resistant tended to have higher spikes, and they tended to have longer duration spikes, particularly for specific carb foods. So you can see the yellow line there is for the potato spikers. So the insulin resistant folks tended to also be potato spikers. And you can see that their spike was a little longer than, say, when they were eating mixed berries or beans. And then the insulin sensitive folks overall had lower responses to all of the carbohydrate meals, but there were different types of meals that made them spike. So for example, they might not have had as large of a response to potatoes, but they did spike more with, interesting to me, honestly, was the mixed berries made these insulin sensitive folks spike more than potatoes would, which it's hard for me to fully, try to understand the physiology behind that. And I think, there's going to be more research to understand that, but it's an interesting finding that deserves more investigation. And maybe you understand, Bret.
Well, what I take, I like to kind of focus on the broad strokes, really, what people can take away from the study as a whole. So, clearly the insulin resistant folks had much worse blood sugar spikes, like you just mentioned about the graph. But just because you were insulin sensitive didn't mean your blood sugar didn't react to the foods as well, which I thought was super
Yeah,
interesting.
that's true.
So it comes down to this concept, right? So now let's take a step back and say, in the US and in other countries, there's a dietary guidelines, which kind of presumes that there's one best way for people to eat. And I like when studies like this come up because I think it sort of flies in the face of that a little bit. So how do you interpret this study in the face of our current dietary guidelines?
Yeah, I mean, I think that's kind of the biggest takeaway I take from this. Why this study matters is that it really points to the need for more personalized nutrition advice. So, the US dietary guidelines is sort of a one size fits all approach right now. And I think as, the our Department of Health and Human Services together with the Department of Agriculture are considering the next version of the US dietary guidelines, they might look to studies like this to offer a sort of a suite of dietary patterns or suggestions depending on an individual's unique metabolic profile.
Yeah. And, so there's like a line sort of that you have to toe, right? Because there's lots of talk about personalized nutrition. And I had a great interview with Gary Taubes where he talked about personalized nutrition. He said, so what you're telling me is that, every individual is going to go to their doctor and get their stool tested, their metabolome, their
Right.
lipidome, their metabolic health, and every single one is going to get diet, 2 version C subcategory X, because that fits their, and it's just not practical, right? Like you get to that point,
Right.
it's not practical, but maybe a little more practical is metabolically healthy, metabolically unhealthy, if you have to start with the broad
That's right.
strokes. Or you say, learn from yourself and use CGMs. So that's the other,
Right.
I guess, slippery slope, right? Some people will say, if you're only looking at CGMs, you focus too much on blood sugar, you become obsessed with blood sugar and not about other things. Or does it direct you to learn for yourself the foods that you respond to or not? So what do you think from a policy standpoint of making CGMs more available?
Yeah, I mean, I think it first of all, I think it depends on the individual. Some people may be more interested and have the ability and time resources to, study their personal CGM data and really make sort of micro changes in their diet as a result. Others might not have the capacity to do that or the interest to do that. So I think, one, it really depends on the individual where we are now. But I think also this opens up a whole space of, potential additional tools that could be developed over time, through additional research or through the help with large, AI models to develop, say, a digital app that can help you interpret your CGM data and help you understand how to modulate your diet, maybe with a little assistance, so that you don't have to go in and be your own individual researcher based on this information that we have today. So that might be, kind of a future, something that is not possible today, but something to look to help us understand how to tailor our diets in the best way for ourselves.
Yeah, and it's interesting. I mean, companies exist that do things like that, but they tend to be kind of expensive and, out of
Yeah.
reach for a lot of people. So, with the
Yes.
government's new focus on metabolic health and sort of their commitment, their stated commitment to address it, could you see something like that? Like, getting this covered by insurance for more people? It seems like that. I don't know.
Yes.
I think it'd be a pretty good movement, but what do you think?
Absolutely. No, I mean, and thank you for bringing it up because I think that's an absolute that is a place where I think the government can play a large role is to take research like this, look at clinical data and see the positive effects that CGMs, continuous ketone monitors, once they are approved by the US FDA, which hopefully that will happen soon. There are other ways to measure ketones, but if they are not available, accessible to people, either they're not on the market yet because they're not approved by the FDA, or they are too expensive because they're not covered by insurance, then people are not going to be able to use these tools. So you really do have to use all of the levers available to us, including allowing them to be used by people and then allowing them to get paid by people, by the government, by insurance. So those are just like sort of two levers I think that the government can pursue to to make these types of tools more available for people to take charge of their own health.
Yeah, and I mean, we talk a lot about we've been talking a lot about the government. I wish sort of we didn't depend on the government, but when you talk about making health interventions and tests available at little to no cost at a wide scale, you kind of do have to have the government involved, I think. Do you agree?
Yeah, I mean, it's true. I mean, some people might say that other types of avenues like better education, resource toolkits can help people. And those I think are really important as well. But at this point, I think, trying to use all the tools in the toolbox and imagining a future in which, all sort of barriers are taken away. There are some things that you really do need, such a huge top down, help with getting some of these things rolled out to make them accessible.
All right, so now we've been talking about this study in terms of, glucose and CGMs and metabolic health, but, here at Metabolic Mind, we talk a lot about mental health. So what do you think the connection is from this study? How do we draw it back to someone's mental health?
Sure. I mean, even though this study is not looking specifically at brain health and mental health, we do know there is that connection between metabolic and mental health. So I think, a takeaway from this could be there's just even more of a reason, especially if you're undergoing mental health treatment, to track your insulin resistance. And, to the extent possible, if you have access to a CGM, to try to understand which particular foods are causing you those big spikes. And, maybe you eat less of that food. I don't know. But it's just, another piece of evidence that metabolic health is influencing our overall well-being, and mental health is incorporated into that.
Yeah, and there are some other studies suggesting a correlation between mood changes and glucose spikes, either spikes or, once the insulin kicks in and then you get the low glucose, that mood changes sort of oscillate with that. So regulating your glucose seems like it could directly regulate your mood as well. So yeah, a CGM could be a really powerful tool for that. So I'd love to see a study like this also showing, momentary mood assessments or something like that to show how it correlates. So, more work to be done, more studies to be done. Seems like there's always more, right?
Absolutely. Look forward to that one.
Yeah. Well, great. Well, thank you so much for joining me to help sort of, elucidate this study and help people kind of learn what they can take away from it, that we're all individuals and we're all going to respond differently to the same foods, and understanding that is so important. So, I love the work you're doing with us at Baszucki Group and Metabolic Mind, but if people wanted to, reach out to you or learn more about what you're doing, where can we direct them to go?
Sure. Yeah. You can find me on LinkedIn, Cristina Nigro. Also, feel free to email me at Baszucki Group, Cristina@BaszuckiGroup.org. It's Cristina, no H. Common mistake. So you don't want to email the wrong Cristina. But I just want to thank you, Bret, for inviting me here. It's a real honor to be asked to participate. So thank you.
Oh, my pleasure. Thank you so much. Fellow mental health clinicians and healthcare providers, you now have access to a suite of free CME lectures on metabolic psychiatry and metabolic health. Each of these CME sessions provide insight on incorporating metabolic therapies for mental illnesses into your practice. These CME sessions are approved for AMA Category 1 credits, CNE nursing credit hours, and continuing education credit for psychologists. And they're completely free of charge on mycme.com.